Good afternoon. In this talk, I will discuss a methodology for modeling submodels in the Industry 4.0 Asset Administration Shell. It is work by the RTOs TNO and DFKI in collaboration with the manufacturing company VDL. I will start with an introduction of what the Asset Administration Shell is. Then I'll continue to our problem statement about development by use case. And then I'll turn to an overview of our methodology, consisting of a technology-independent description and a Industry 4.0 compliancy phase. And I will conclude with an example application of our work. The Asset Administration Shell, or AAS for short, is the Industry 4.0 implementation of a digital twin. And several publications have already been published by the platform Industry 4.0, and that is what we base a lot of our technological background on. So I'll turn to the fundamentals of the AAS. The AAS is the communication shell of an asset in the factory. On the left-hand side of the equation here, you can see in gray an asset, which can be a machine or anything of value in the factory, but also something immaterial, such as work orders and process steps, and anything else of value. And on the right-hand side, you see the contents of the administration shell, consisting of various submodels in the body. And the submodels here are important because that is where the standardization happens. First of all, on the level of individual properties. For example, this manufacturer name gains a global ID through its E-class identifier, but also on the level of functionalities. Also on that level is the submodel a standardized representation, because each submodel pertains to a specific functionality. So various submodels have already been proposed on various topics for machines such as engineering, identification, lifecycle status, but also on specific types of machine such as drilling, milling, clamping, etc. And these together provide a functional and standardized view of the machine. But the problems that we encountered was the question of how to choose among the whole list of submodels, which submodels are relevant to your use case, to your scenario. In particular, in our scenario, we found that we lacked submodels for immaterial assets, such as work orders and process steps, because also those are very important for a shop floor factory. And there was no methodology on how to produce the set of submodels required for a particular scenario. And such a submodel definitely is needed to provide guidance which is needed for increased adoption. At the moment, there already exists a methodology to build a submodel based on a standard. So how to make an established standard such as an OpenCUA companion specification AAS compliant. This takes a specific look at one standard and produces a single submodel out of it. But what we produced in our work is a use case based methodology. So we want to elicit requirements from a factory situation, take the whole scenario into account, and produce or identify the set of submodels that is needed. So how would such a methodology that identifies submodels based on use case description look like? We identified three phases at the bottom of the screen: the knowledge representation phase, the Industry 4.0 compliancy phase, and an evaluation phase. And the knowledge presentation phase consists of building a conceptual model, such as the example given here on the screen. This makes sure that the conceptual modeling can be done in collaboration with the domain experts, and that the Industry 4.0 experts or the AAS experts are included when the conceptual model is really turned into an implementation. And this separates the concerns of modeling the scenario and implementing it. So the Industry 4.0 compliancy phase will involve turning this conceptual model into one containing the specific AASs for each asset in the factory. And it also consists of adding the various submodels of the various functionalities to it. When we take a detailed look at the knowledge representation phase, we see requirements analysis and the actual conceptual modeling and an intermediate evaluation step. We take inspiration from various ontology development procedures for this knowledge representation phase, and it resembles the conceptual phase of various ontology engineering methods. In the Industry 4.0 compliancy phase, we identify 4 steps that are relevant really for steps specific to the AAS technology. So, separation by functionality, adding the specific submodel elements, aligning the submodels with the AASs, and assigning semantics. At the moment I can't go into detail on each of those steps, but in the paper we provide best practices for each of those. And I will go into some detail on assigning semantics. And we conclude with an evaluation phase consisting of verification and validation. For example, in the step of assigning semantics, we provide best practice to reuse existing properties. For example, reuse from vocabularies such as E-class and IEC, but also to reuse properties from other established standards and established ontologies through identification with a IRI or URI. But we also provide best practices for reuse of submodels from existing registries of submodels, such as the Common Information Model currently being developed in the DIMOFAC project, but also the digital nameplate and identification submodels already published by Industry 4.0. So, how would the results of an example application look like? So here you see the configuration of various AASs consisting of work order AAS and process steps AASs that together make up the AASs we developed for this scenario. And here in purple you'll see the actual data objects relations, whereas in green you see the flow of the various parts throughout the factory. So if you're watching this on demand, you can take a moment to pause here. So our work delivers on 2 fronts. First of all, we have developed submodels for immaterial assets we found lacking, namely the work order and the process step. And secondly, we have developed an initial version of a submodel development methodology based on a use case description that produces a set of submodels that is necessary to model a particular factory scenario. And we have taken particular care at separating concerns between conceptual modeling and making the conceptual model Industry 4.0 compliant. So thank you for your attention.